This introduction to Euclidean geometry provides basic concepts and serves as a requirement for grade 10 to 12 geometry. I highly recommend that you begin your journey of Euclidean geometry from these lessons. I was fortunate enough to study Euclid's original postulates. For that reason, I love Euclidean geometry so much. And I'm excited to share with you this beautiful part of mathematics. In lesson 1, we'll look at a number of definitions that are important for us to understand this topic. We will begin by looking at the definition of what a theorem is. A theorem can be understood to be a logical statement that has been proved to be true. When we say the statement is logical, it means that it has reasoning in it. It makes sense. There's some form of structure. Theorems have the following logic or structure. If A, then B. That's how we structure our theorems. We write them as sentences that have the A part and the B part. And you can see from this statement that we say we start with A, then we can conclude B. So that means the A part is actually what we begin with, is the given information or the given data, is what we have or what we propose. It can be understood to be the hypothesis. Because of that hypothesis, then we can conclude the B part. So the B part becomes a conclusion. Sometimes we call the B part the required to prove RTP statement, because it's the part that we'll have to prove. Remember, we said here that a theorem has to be proved to be true. So the B part is what we'll have to prove, but the A part is what we begin with, is what we know. I have an example here of a statement that has this structure that will give us a feel of what a theorem is. Suppose that we say that here, if you fail mathematics, then you do not understand the basic concepts. If you look at the first part of this statement here, is what we call the A part, is what we begin with, is what we know, that you have failed mathematics. Then the second part here, the B part, is what we can conclude to say for you to fail mathematics, it means that you do not understand the basic concepts. And we might need to prove the B part on the basis of the A part, looking at the A part. Theorems have what is called converses. So a converse is simply a reverse logical statement of a theorem. In other words, we take the theorem that we have, let's say in this instance, this one, and we write it in a reverse way. So that means we take the B part, this part, we make it the A part. And we take this A part, we make it the B part. It then now becomes the B part. So that means we'll begin our statement with what used to be the B part on our theorem and conclude what used to be the A part. For example, using the same example there, we'll say here that if you do not understand the basic concepts, then you will fail mathematics. Do you see here we begin with this? We know that you do not understand the basic concepts. Then we can conclude that you will fail mathematics. Now, the important thing to notice here is that if this converse is to be proved to be true, it then becomes a new theorem on its own, even though we know that, it's a reverse of what used to be the original theorem. However, it is not always the case that converses can be proved to be true. So that means some theorems will never have converses. The other concept that we need to understand or know is what we call corollary. A corollary is a logical statement that is derived from the theorem. I think the key word here is derived. When we say something is derived, we mean that it comes from, it originates from. So corollaries, they originate or they come from theorems. That is to say, if we look at our theorem here, the example that I gave here, this theorem talks about failing and what happens when you fail. From this theorem, we can deduce or we can come up with another statement that talks about what happens when actually you pass. And in fact, I can write a statement where I say, if you pass mathematics, then you understand the basic concepts. Do you see that this statement is actually inspired, or we are building it from the fact that we know that if you fail, you do not understand the basic concepts. Then we can reverse things here and look at them from the perspective of what happens when you pass. It will then mean you understand the basic concepts. Such a statement is called a corollary. And again, you have to notice that a corollary has the same structure as the theorem. Is still a logical statement. In other words, it has the A part and the B part. So we still have here if A then B statement. We still have if A then B statement, even though it was derived from a theorem. Now, the last thing that we have to know about corollaries is that they must always be true because they come from theorems, and a theorem already has been proved to be true. So if we pull a statement from something that is already true, that statement must also be true.